Good afternoon. Welcome to problem 6.12. I have the free body diagram written up on the board. There is a pin connection at point A and a roller at B. So AX and AY for the pin connection and a roller perpendicular to the plane or the surface it's sitting on, EY. The structure is in equilibrium. Because of that, first thing that allows us to use the equilibrium equations to calculate what's going on at the reaction. So that's where I'm going to start. I'm noticing right away that the summation of forces in the x direction only include AX, which is equal to 0. So I'll go ahead and put that over here. That is 0 kilonewtons. I could take the summation of forces about the y direction right now, but there's two unknowns, both AY and EY. So I'm going to start with summation of the moments about point A. There are several forces into effect. There's the 10 kilonewton force at point B with a perpendicular distance between A and B of 3 meters. There's a 10 kilonewton force at point C with a perpendicular distance of 6 meters. There's another 10 kilonewton force at point D. You guessed it, 9 meters away. And finally, the force at EY, which is 12 meters away. The summation of those is equal to 0 because it's the equilibrium. Picking up the rotation direction, if we are rotating about point A and we're pushing down at point B, that causes a clockwise rotation, which is negative. Same thing for the forces at C and D. The force at E causes a counterclockwise rotation, which is positive. Performing the indicated arithmetic, you get negative 180 kilonewton meters is equal to EY, negative EY times 12 meters, giving us EY is equal to 15 kilonewtons. The fact that it's positive just indicates that I have the correct direction guessed. 15 kilonewtons. Now we can take the summation of the forces in the y direction. So it's AY up, minus 10 at B, minus 10 at C, minus 10 at D, plus 15 at E, equal to 0. Put my units in real quick. Negative 10, minus 10, plus 15 is negative 15 or minus 15. Solving for AY, we get AY is equal to 15 kilonewtons. I'm going to pause right here while I get the board raised. See you in a minute. Okay, I want to look at a couple things before we get started into the next phase of our work. I want you to look at the structure and notice that the structure is exactly symmetrical. What is in one side of the structure is the same as on the other side of the structure. I'm going to just draw a kind of line right here so we can look at it. I'll erase it in a minute. The only thing that's different on the left-hand side is you have AX, and we said that AX was equal to 0, so I'm going to erase that. Now notice that it's exactly the same. All right, so the distances are the same, the angles are the same, and the applied forces are the same on both sides. Because this structure is symmetrical, that means that the forces are distributed symmetrically to their corresponding parts on the other side of the structure. So for example, AB has a corresponding member at ED. So their forces are going to be exactly equal. AG and EF are exactly the same. BG and DF correspond. BC and CD correspond. CG and CF correspond. and GF is right in the middle. Okay. So that's a handy piece of information to know, because what that just tells me is I only have to work out half the members, or a little over half the members. Okay. All right. Next thing I want to talk about is I found while I was working this problem that I'd get to a pin and I'd need an angle, or I'd need a length or a distance. And I found myself, maybe this happens to you guys and gals too, I found myself with tons of pieces of paper all over my desk. I've got some measurements here and some measurements here, and there's some measurements. I got an index card with the measurement. So when I got done working all the problem to get ready to record today, I said, you know what, I'm going to put all that data on one piece of paper. So I'm going to work out all the various measurements that I found myself needing over the course of working this problem, and I'm going to put them on the screen right now. And when I get done, what I would recommend you doing is pausing the video and taking a picture of the screen so you can refer back to that as we pick up those measurements as we work the rest of the problem. That way, in no way did they just come out of thin air. I mean, I've done the work. I'm going to show you the work. But I found it a little bit neater for me to organize all that on one sheet of paper. Okay. All right, so again, just as a reminder, I'm going to go through the various measurements that I needed in order to solve the problem. It just helped me put everything in one place. Hopefully it'll help you as well. All right, so the first thing I noticed that I was going to need, or at some point while I was working the problem, I determined that I needed to know what is the angle at point A. What is the angle at point A? So I knew a couple measurements. I knew that this height was 4 meters and that this length was 6 meters. And that's given in the problem, right? So 4 meters tall from point C to the horizontal, and then the horizontal distance between point A and point C is 6 meters. That allowed me to get this angle right here. So we can use the arctan function for that. Arctan of 4/6. And if you punch that into the calculator, you get that theta, or that angle, is 33.69 degrees. I'm going to fill that in. 33.69 degrees. At some point, I needed to know what the distance between A and C was. So I can use the Pythagorean theorem for that. 4 squared plus 6 squared is equal to AC squared. So that's 16 square meters plus 36 square meters is equal to AC squared. Take the square, 16 plus 36 is 52 square meters, equal to AC squared. Take the square root of both sides, and we get AC is equal to 7.2111 meter. Okay. 7.211 meter. I'll go ahead and write that. Let's see, what can I do? I'll use Brown. 7.2111 meter. Okay. At some point I figured out, well, I reminded myself anyway, that if angle A is 33.69 and this is a 90-degree angle, then this angle that I'm pointing to must be 90 minus 33.69, which, as you probably have already guessed, is equal to 56.31 degrees. At some point when I was working the problem, I discovered I needed to know how long AB was. How long is member AB? So that was also I thought that was a fairly easy one to figure out. I know the height is 2 meters. I know this side is 3 meters. I can use the Pythagorean theorem. AB squared is equal to 2 meters squared plus 3 meters squared. So AB squared equal to, that's not 9 meters. I meant to say 13 meters. I was just joking, yeah. 13 meters squared, which meant that AB comes out to be, you guessed it, 3.6056 meters. Circle that, and then I'll annotate it on the picture so that it's a little bit easier to find for you. 6056, 3.6056 meters. At some point, I decided I needed to know how long, remember, AG was. Now, we had already determined that this was, that's A, B, and G. We determined that this was 3.6056 meters. And I knew that this angle was 33.69 degrees. So I can go out and say that the cosine of 33.69 degrees is equal to 3.6056 meters divided by AG, and AG is equal to 4.33 meters. Circle and annotate for us. 4.33 meters. At some point, I determined that I needed a measurement, and it's going to look, it's not going to look weird. I just said that for no reason. Here's point A. There's point G. A point C is right here, looking on your triangle. I decided that I needed to know, I'm going to call this C prime. I needed to know the distance between G and C prime. I know AG, 4.33 meters. I know from A to C prime is 6 meters. So 6 meters minus 4.33 meters is equal to 1.67 meters. So that's right here. Next one I had was GC. So let's see. There's point G, point C. I determined that I needed to know the angle between the horizon and GC. We're given this is 4 meters. We calculated this as 1.67 meters. So this angle is arctan 4 over 1.67 meters, giving us an angle measurement of 67.34 degrees. .34 degrees. I also determined I needed to know the length of GC. So to find the length of GC, use the Pythagorean theorem. GC squared is equal to 4 meters squared plus 1.67 meters squared, giving us that GC is equal to 4.33 meters. Which I guess shouldn't be a surprise. BC. Okay. At some point, I was looking at the triangle BCG. Oh. So B, C, G. So let's see, I have a couple pieces of information. I know that BC is the same as, how did I get that? Hold on one second. All right, so BC, I know that from this calculation that AC is 7.2111. That's a fact. I know that AB is 3.6056 meters, so that's a fact. So that BC would be essentially AC minus AB is equal to length BC, and it comes out to be 3.6056. 3.6056 meters. We just calculated distance CG as 4.33 meters. So I can take the inverse cosine of 3.6056 meters divided by 4.33 meters. And that gives me the theta, which is this angle right here. Therefore, theta is equal to 33.62 degrees. 33.62 degrees, which is right here. Which gives us, this is 56.37. I think it's 56.37. 56.37 degrees. That's this one right here. And the last thing I have written down on my paper is, for some reason, I needed to know the angle. This one is a little bit weird. Let me get a different color. That's B. That's C. Needed to know this angle right here. We know that this is 2 meters. We know this is 3 meters. That's given in the problem. So the theta in this particular example is arctan 2/3, which is equal to 33.69 degrees. Okay. So that's my pre-work. I'm gonna pause the video, and I think what I'm gonna do is I'm gonna save this as part 1 of the video, and then we'll start with part 2 in a second.